So one of the things that has always struck me about water, apart from the fact that it is such a central part of people's lives, is that it is so much a part of all other issues of sustainability, be it climate change and global warming, or biodiversity loss, or for that matter, the way water is gets used up in energy production, as well as, of course, to the issues of food and agriculture. So what do you think about this?
Well, the fact of the matter is that India still is a monsoon-driven nation. Now, we get about 4,000 billion cubic meters of rain falling on this continent of ours, the 3.3 million square kilometers of area we have. But most of it occurs during 3 months of July, August, and September. And this seems to drive the life of the farmer. He needs water on his field, he needs water in the lakes, rivers, and in his wells. But it also drives the lives of cities and industries, because industries, for example, need power, and electricity has to be generated from coal, or it has to be generated from nuclear power plants, or even hydroelectric plants.
Right.
These dams have to fill up, and they have to wait for the rains to fill up. If the rains don't fill up the dams, and if there's no water in the river, we don't have power, we don't have electricity. On the climate change front, we are facing problems because the monsoon is now becoming extremely severe or sometimes very short.
Right.
And when the monsoon starts to fail, it starts to affect our forests and jungles. Forests have forest fires, plants and trees are cut, biodiversity is affected, insects and birds start to disappear. So the rains still really dominate Indian life and
Right.
drive us.
Right. And the linkages seem to be all over the place. For example, as much as if in the event of water scarcity, your forests dry up, the rivers also. If you deforest, then your water runoffs increase, and your water conservation on the ground goes for a toss, right? So it works both ways.
Absolutely. So one of the things that is nice for students to do, and even ordinary people to do, is to stick a rain gauge in their house or in the school and to start to understand how much does it rain in a year. And then to start to look around, see what happens with the rainfall that has fallen to the rivers and streams and the wells.
Right.
And to the crops growing around their schools and colleges. Also to start to understand from the newspapers what is happening to the city because of lack of rainfall or because of too much rainfall.
Right.
And then you will be amazed that it seems to affect your life on a day-to-day basis.
Right. I read this very interesting and also at the same time alarming fact that apparently all the major rivers of the world, the Nile, the Ganga, the Colorado, and so on, during the dry season, they no longer flow to the sea.
That's a tragic fact. They become what are called closed basins, that it's only in a few days, especially during heavy rains, that they reach the sea. And this has dramatic impacts, as you would imagine. One of the direct impacts is that the seawater starts to come in, and the river starts to become saline, the soil around becomes saline, and the groundwater below becomes saline.
Right.
And many people live on the coastal areas,
Right.
and they are affected by the salinity because we've used up the water in the rivers
Right.
upstreams.
Right.
So rivers have to be seen more as ecological flows, and rivers are more than water. Rivers foster life, rivers have fish in them, dolphins in them, so many other things. But also importantly, rivers have to take sediments to the sea
Right.
so that the fish can have
Right.
food to eat.
Yeah. Otherwise, you have what are called dead marine zones, right?
Nitrate contamination
Right.
coming in through sewage,
Right.
wastewater which flows from our cities, getting into our rivers and streams, ultimately reaching the sea and rendering it sterile, killing all living things within zones of 10 to 15 kilometers sometimes.
Right. Right. So the climate change water linkages seem to be particularly very intriguing and interesting. Most of our school children learn about the water cycle, in school. And if one sort of tries to understand it very intuitively, really what's happening is, water evaporates, goes through a cycle, condenses, falls back to the ground, and that cycle keeps going on and on. I was reading something interesting about how one part of the water cycle is affected due to climate change, particularly due to rivers not flowing into the seas. Can you talk about it?
Well, there's a bit of research going on in the Bay of Bengal as to what happens if fresh water does not reach the sea. Previously, fresh water would go into the sea and create a lens or a surface layer which could evaporate easily. Now that rivers don't reach the sea, there is a saline layer formed on top, and it's not easy to evaporate saline layer.
Right.
Even the sun finds it a bit difficult.
Right.
So the amount of vapors entering the hydrological cycle start to become less and are affected. So does that mean less rains?
Right.
It's a question that science is exploring and trying to find answers to.
Right.
The other interesting part about the hydrological cycle is fascinating, that rain falls on our rooftops. I know of people, friends of mine, who picked the rainwater, filtered it, and led it into an open well. And the open well water have started to rise.
Right.
Precisely because fresh water stays on top of saline water. And so you have a freshwater bubble which you can start to use. And this has energy connotations too. The higher the water in your wells, the less electricity or energy we use to pump it up.
Pump it up, yeah.
The same water, if it's pumped from a deep bore well, consumes 4 times more energy. And in cities like Bangalore, if water has to be pumped from a distance of 100 kilometers, it requires almost 2 units of energy to pump 1,000 liters of water. So the hydrological cycle,
Right.
its effect starts to impact climate change, starts to impact energy consumption,
Right.
and is a self-reinforcing loop. The more energy we consume, the more carbon emissions,
Right.
and therefore more climate change. The less energy we consume, the better for the carbon emissions, the better for the weather.
So it's a typical self-reinforcing loop, which can be bad or good depending on which way you go.
Exactly. We have to
Right.
start to turn the vicious cycle into what we call the virtuous cycle,
Virtuous cycle.
or the virtuous cycle, and to get that going.
Right.
One another anecdote with water is that in rural India, especially peninsular rural India, in the so-called Deccan Plateau, most children learn to swim in open wells.
Right.
If the water table falls because we overpump our aquifers, many children lose the fine art of swimming, and an entire generation can come up without knowing how to swim. And this is what one is observing a lot in India, unfortunately.
Absolutely. And so that sort of brings up the the cultural aspect of water, which is so interwoven into our lives, right?
True.
So
That we are named Hindustan, or the people across the river Sindhu,
Right.
or India, which also comes from the Sindhu or the Indus River, is describing us civilizationally as a water civilization. And actually we have been a groundwater civilization for a long time. Wells in India start from the Harappan era. If you go to Mohenjo-daro, Harappa, Dholavira, you still find wells. The old people used to use wells.
Right.
And those wells still help us survive in the modern day too, because we've changed the well into a bore well, but it's still groundwater.
right. While there are many such examples of interlinkages of water, I think the last one that I wanted to touch upon was that of the issue of water in agriculture and food,
Yeah.
right? So, and again, there are several examples, particularly the Green Revolution and what it has meant over the years. So can you talk about that?
Well, we started the Green Revolution in the 60s. We brought in hybrid seeds, we brought in fertilizers,
Right.
we brought in pesticides, and we brought in water.
Right.
And the water came from groundwater.
Right.
There was an explosion of bore wells all across India. The end result is that we have food self-sufficiency, but we have 30 million bore wells.
Right.
And we have 250 cubic kilometers of water being pumped from our aquifers every year.
Right.
This makes us the number 1 users of groundwater in the world. So we have to learn our own lessons as to how do we ensure that we use this water sustainably. On the other hand, we've had a problem with the use of fertilizers because they have run into our water bodies, into our streams and rivers.
Right.
They've started to pollute them with nitrate, and they've started to make water unusable. So we have to start to learn how to lessen the use of fertilizers, how to shift to organic cultivation, and how to stop pollution of our surface water bodies and groundwater bodies. The Green Revolution has given us food, but has also given us 2 major water problems:
Right.
groundwater depletion and surface water pollution.
And then that's a very, I would say, typical of this core issue of sustainability of the short term versus the long term. What could be good in the short term can be entirely reversed in the long term. right?
We seem to be past masters in developing problems and finding solutions for new problems, creating newer problems and then finding solutions. Somehow we have to start to break away from that
Right.
methodology and try to be a bit more sustainable and a bit more long term, as you rightly put it, for our issues with water especially.
Right. And the other major issue of water and agriculture is that of land use change, where you are cutting down forests in order to grow food for more and more people, in particular corn and soy, right? So can you tell us something about that?
Well, two things are happening. One is that the population is increasing. Two is that there's economic growth. And three, there's a demand for fuel, which is called biofuel now in certain areas. In India, the problem is not so severe, but in parts of the world like Brazil, for example, large tracts of land are being brought under soybean, under biofuel crops. This is leading to forest depletion, biodiversity loss, as well as soil and water pollution.
Right. And these crops actually require a lot more water, right, as well.
Yes, sugarcane and other crops are extremely water consuming and can cause drought.
Can cause drought.
Yes, and cause water shortage during summers, as we saw in Maharashtra and Gujarat part of this year.
Right. So I think it would be a fair characterization to say that water is unique in several respects, of course, but it's also unique from other issues in that it's at the center of almost every other issue, right?
We need to treat water with a lot of respect. School children can step out of the school and see what's happening to the drains, stormwater drain, and from there start to learn lessons how to keep our water bodies free, clean, and good quality, and then from on learn how to use water wisely. We need to be a wise water civilization, and that's in the hands of the new generation.
We think that Earthian is a great opportunity for students and teachers in schools and colleges to involve and engage in some of the most pressing issues that face us. We know that environment education is there in some degree or the other, in our schools. What we are offering through Earthian is a platform to not only build upon that, but also to collaborate, to interact with many others. Those others could be other schools, those others could be partners, so many other people who bring in a rich variety of perspectives. And therefore, we exhort you to participate in Earthian 2013 with all that you have in terms of your enthusiasm, your passion, your interest, which we have seen enough of over the last 2 years.